Hi, my name is Brent and this is Brian. Okay, today we will be doing a video to find out the densities of a regular and irregular object. For a regular object, we have chosen to use a 50-cent coin, and for an irregular object, we have chosen to use a rock from our school. We will first measure the mass of these objects, and then we will measure the volume in order to calculate the densities of these objects. First, we will measure the mass of the rock. In order to increase the precision of the results, we have to take several readings. Okay, now we shall measure the mass of the coin. 50-cent coin. Oh, freak. Okay, now we are done measuring the mass. Moving on. Now my partner Brian will be measuring the volume of the stone through the displacement method.
Stone and string.
We will wait for the last drop.
And drip.
Okay, now we shall check the volume. Putting it on an even surface, you see, look at the value of the meniscus. It reads 9 cm cube. Now we will be using the micrometer screw gauge to measure the diameter and the thickness of our 50-cent coin. Okay, as you can see, the micrometer screw gauge that we are using has a zero error of negative 0.01 mm. Okay. Now we shall measure the thickness of the coin. Now we shall use the fine-tuning knob to adjust. Okay. Now we shall read the reading on the vernier, on the main scale. The main scale reads a reading of approximately 1.5 mm, and the vernier scale reads has a reading of 0.32 mm. Okay, now we shall take the measurement 2 more times to increase the precision. Now we shall measure the diameter of our 50-cent coin with a vernier caliper. As you can see, this vernier caliper does not have a zero error. Now we shall measure. The main scale reads a reading of 2.4 cm, while the vernier scale reads a reading of 0.7 cm. Now we shall take several readings. One more time. Okay, now we shall tabulate all the data onto a whiteboard. As you can see, we have now tabulated the data from our previous measurements, and we have calculated the density of each of these. This is the density for the 50-cent coin, and this is the density for our stone. And so we derive that the density of the coin is higher than that of the stone. Thank you for watching.